welcome to this presentation on multi-cloud serverless with Micronaut and GraalVM. Thanks for all those who have come to attend. I hope you enjoyed the presentation. Should be a lot of fun, and with lots of live coding demos. My name is Graeme Rocher. I'm an architect at Oracle Labs, where I lead our Oracle's and efforts around Micronaut, and work closely with the GraalVM team to optimize Micronaut for cloud-native workloads. For those of you who haven't heard of Micronaut, Micronaut is a relatively new framework for the Java ecosystem that is focused on modern architectures like serverless and microservices. But it's also a complete application framework for any type of application, really, as long as your application has a static void main. It's Micronaut. It essentially, the difference between Micronaut and traditional frameworks is that it hooks into the Java C compilation process and computes all of the way the framework works at compilation time. It was the first framework to do this kind of build time ahead of time approach to computing how the framework works. And the end result of that is an architecture which is completely reflection-free, runtime, generate proxy-free. We don't use bytecode generation at runtime. We don't use dynamic class loading on Micronaut. And all of that results in smaller, more efficient, faster applications. By default, it has an HTTP client and server based on the Netty IO toolkit. But the whole design of Micronaut is very pluggable and extensible, such that you, like I said, can use it for any kind of application. We have, in fact, folks using Micronaut's dependency injection and aspect-oriented programming features in the context of swing applications and command line applications and message-driven headless microservices. Lots of different things. So you can find out more about Micronaut at micronaut.io, and do check out the source code on Micronaut projects /Micronaut core, and do star the repository. Every star is appreciated, and follow the work that's continued to go be undertaken by what's now like a multi-vendor open source project with investment from lots of different companies. It's a very exciting time to be a Java developer, with Micronaut being one of the reasons for that. So, Micronaut has a very close relationship with GraalVM, and has done, since its initial release, in that because Micronaut computes the way your application works at compilation time, eliminating the need for reflection, dynamic class loading. That leads to GraalVM's native image tool, and I believe there was a native image presentation prior to my one, having an easier job in terms of performing a closed world static analysis of your application, because there's really little configuration you have to pass to native image to get it to work with the Micronaut application. Because everything in Micronaut is statically reachable for the static analysis tool. But GraalVM is a lot more than native image. It's also plugs into the regulated JDK and as a replacement JIT, and which is able to reduce able to increase application throughput and reduce latency. It also features Truffle, which is a language framework, and has implementations on top of Truffle for things like Python, JavaScript, and so forth. JDK 17 support in GraalVM, with JDK 17 just coming out as well, is on the way. The GraalVM 21.3 release will be coming out in the next couple of weeks with dedicated JDK 17 support. But in the meantime, you can develop builds. And of course, the JDK 11 support is there already. You can find out more about GraalVM at graalvm.org, and check out the demos in the GitHub repository. So let's go on to the Micronaut plus serverless. Micronaut features a low-level integration with different serverless platforms and APIs. Integrating directly with Lambda, Oracle function, Google Cloud function, so forth. And in addition to, that, it features a higher level abstraction for writing HTTP functions, which uses a traditional annotation-based programming model. And these kinds of functions typically run behind an API gateway, but not always. So in the case of Lambda, you would use API gateway proxy, and Oracle function as well. There's also an API gateway that you put in front of your functions. In the serverless space, memory usage and startup time with regards to cold starts can be a big factor in the design of your application or the applicability of a serverless architecture to your application. And because of how fast Micronaut is, and also the integration with GraalVM native image, you can build native functions and deploy them to a variety of serverless platforms, including Lambda, Oracle function, and so forth. So the design of Micronaut is a good fit for serverless architectures in general. Micronaut features dedicated modules for each cloud, and that provides integration with the underlying function or serverless platform. So on Oracle Cloud, there is integration with Oracle function, which lets you write Oracle functions and deploy them to Oracle Cloud. Same thing on Google Cloud. So we have a dedicated GCP module that allows you to build applications that target both of Google's serverless platforms, Google Cloud Function for Java, and also Cloud Run. And on the AWS side, there's an AWS module that lets you build applications that integrate with Lambda and completely serverless. And again, for Azure, we provide integration with Azure function in Micronaut. So broad multi-cloud support for different serverless platforms exists within Micronaut. So how do you get started building serverless applications? So with Micronaut. So a good way to do that is to head over to Micronaut launch, which is available at start.micronaut.io, which will redirect you to this site. And you can use the application generator to select one of the serverless platforms. So you can click the features button and choose either Oracle function, Lambda, Google Cloud function, or Azure function, and it will generate a project that is already out of the blocks deployable to those platforms. It's not strictly necessary to use the application generator, but you can, define everything from scratch. But it's definitely handy that you can go this way. If you don't like web UIs, you can also use curl. So this slide features the different commands that you can use to use Micronaut launch to generate applications that are deployable to each of the serverless platforms that the different cloud providers provide. So just copying and pasting those different commands into your terminal, and you will generate a demo.zip file, which you can extract and immediately get started. Of course, if you go the launch route, if you click you can obviously customize the language, the build tool you want to use, the test framework. There's many different options to how you want to generate your application. This command here will just generate with the defaults. Micronaut launch, in fact, is an interesting application to look at if you're interested in multi-cloud serverless applications, because it is in fact a multi-cloud serverless application. The front end for Micronaut launch is written in React as a kind of JavaScript-rich web application, but the back end is written in Micronaut, and it's continuously deployed to a variety of different serverless platforms. And we use it as kind of a test bed for evolving Micronaut support for multi-cloud serverless. So the sources for Micronaut launch are available at that repository in the link below. But essentially, we continuously deploy Micronaut launch the entire backend for generating applications to AWS Lambda, to Google Cloud Run, to Azure Function, and to Oracle Function. The cool thing here is it's a showcase of how you can build a single application that is cloud portable, right? Cloud portability is a big part of Micronaut's story, where it's, Micronaut is natively cloud native. And if you write an application, you want to be able to easily move it from one platform to another, and redeploy. That's the benefit of using a framework to enable those abstractions and allow you to pick the cloud platform that you want to deploy to and seamlessly enable that. So I mentioned before that there are a difference in the Micronaut has kind of two levels of integration with serverless platforms. One is native functions, where you extend directly from a kind of cloud specific API. So in Lambda, this is like the request handler interfaces that are part of the SDK for Lambda, the AWS SDK. In Oracle Function, we have some Oracle Cloud specific APIs that you extend from. And the benefit of using Micronaut for these kind of lower level functions is you can integrate automatically with a dependency injection in terms of injecting different components into the application. So if you want to inject, for example, Micronaut to manage, for example, the life cycle of your cloud SDK components, for example, S3 API or cloud storage or on Oracle Cloud or object storage, etc., you can dependency inject those components into your function and interoperate with them. And also you can consume directly native cloud events, whether that's being, for example, on AWS S3 events or for writing the kind of functions that respond to your cloud infrastructure. The thing to note about this approach is that we're providing, with Micronaut support for serverless, we want to provide access to the native cloud platform. So you're not taking any power away, by too many levels of abstraction. But obviously, when you write these kinds of native functions, you're working directly with the cloud APIs or SDKs for that particular cloud. So that's the support for kind of native functions that Micronaut has. But in addition to that, Micronaut supports HTTP functions, and serverless applications. So what that means is that with this approach, you use the standard programming model that you use for building normal Micronaut apps. And in fact, you could use JAX-RS annotations if you add the JAX-RS module for Micronaut, whichever one annotation programming model that you prefer. But the key here is you're defining controllers using add controller and using get, post, put, and the normal kind of programming model that exists for traditional applications. So you're not using anything cloud specific. And these kinds of serverless applications, and this is how Micronaut launch is written, are essentially typically run behind an API gateway. Not always, though. In the case with Cloud Run integration, for example, you just, it just runs automatically and exposed over HTTP. But essentially, you're writing a traditional web application, and this means the code is portable across different cloud platforms, and there's no cloud-specific APIs necessarily in play here, although you can. And the way Micronaut is designed, you can easily wire in different components for different clouds. So let's get to the demo section of this, and I must pre-warn you that if any of you have been to any of my talks before, I do everything live coding and live demos, and this has a higher risk factor of going terribly wrong when I'm engaging, different cloud platforms. Who knows? Facebook might go down in the middle of my talk, and or some disruption with Amazon Cloud or something. Who knows what could go wrong? So so this is going to be a lot of fun. We're going to do some live coding, and hopefully it all goes well, and you have an idea of what you can do with Micronaut. So what I have here is my VS Code editor with Micronaut tooling, the GraalVM tools for Java installed. And what I'm going to do is I'm going to start off by creating a new Micronaut project. So I'm just going to create with the latest version, which is 3.0.3. And I'm going to create a standard Micronaut application using GraalVM 21.2 as my JDK. And we're going to call it Serverless demo. Just provide a base package. We're going to use Java as the language. This whole application generator that's integrated into VS Code, just for your information, is using that Micronaut launch backend, which is another multi-cloud serverless application running in the background. So I'm going to just go with the standard features. You can actually go ahead and pick features from here, like if you wanted to integrate support for open API generation and that kind of thing. But I'm not going to do anything. I'm going to use Gradle as the build tool, JUnit as my test framework. And I'm going to create the application in my JCON demos directory and create it. Yes, I want to trust this project. Okay, so here is a Micronaut project. So I'm using Gradle as build tool, but I could have chosen Maven as well. It's a standard Java project with a source main Java. And we have a application entry point where we can enter, run my application directly from the IDE. There's also a test, and which enables me to test my application. And so if I, start my application up here, for example, it'll start up my Micronaut server. It's available on port 8080, and my application is up and running. And in addition to that, we have a test application here. It's annotated with Micronaut test. So from here, we can run integration tests. What Micronaut test does to a JUnit 5 test is it essentially bootstraps JUnit Micronaut before the JUnit 5 test runs, and allows me to dependency inject components. So it allows me to spin up a kind of integration test out of the box. And you'll notice that one of the great benefits of Micronaut being so fast and so efficient is just how fast integration tests execute. So they execute ridiculously fast, even though this is like starting up my server and running everything. So what I'm going to do is I'm going to just build a little example application that we can deploy to different serverless platforms. So I'm going to create a new book controller for a bookstore, and I'm going to annotate it with @controller and the books URI kind of thing. And what I'm going to do is I'm going to create another class which is going to be a interface for called book service. And in here we're going to just list some titles of books, just as a kind of example. So this book service interface could theoretically be calling a database or whatever, and we're going to provide implementations for that. So with Micronaut, you can very easily dependency inject. My preference is always to use constructor injection to generate to inject into the constructor, rather than, I know some people have preferred Jakarta.inject and field injection. But constructor injection, I think, generally is superior, as it kind of more clearly expresses the requirements that my class needs this to operate. And I'm just going to add a get endpoint that is going to use this service to expose under the books URI the different book titles, and add an import for that. So pretty simple. Now, the way I would, the only thing I'm kind of missing is a default implementation of this. So I'm going to provide that, and we're going to create a new default book service implementation. And I'll explain the reason why we're introducing this kind of level of abstraction later in my talk, but we want to implement this interface and annotate it with @singleton. Micronaut 3 is based on the Jakarta inject JSR 330 specifications, so you can use all those kind of typical inject annotations. And what we can do is just to return a list for the moment of titles. So let's do list of learning Micronaut, understanding Micronaut, etc. And do a couple of return some data from my controller. So this is an implementation of the book service, and it's being injected into my controller over the books URI, and it is available automatically to my application. So what I'm going to do now is I'm going to write a test for this, right? So I'm going to write a test that tests that this actually works. Because one of the big challenges with serverless applications for writing them into Java is like getting kind of integration tests for your lambdas and so forth without engaging all of the platform. And by using Micronaut's support for integration testing, you can essentially write tests like you would normally to do any kind of application. So I'm just building a standard Micronaut application here, and I'm going to add that same endpoint from here to basically like list all of the titles like so. So this is my, what I'm doing here is defining a declarative client using Micronaut's @client annotation, which allows you to implement HTTP clients declaratively really easily. And I'm just scoping it to my test. So this will only be available within the context of my test, which is pretty nice. So with that, I can list the kind of results and basically assign those to a variable, and maybe do something like set equals to result.size to have a proper integration test. We can always replace that with static import. And basically, if I run this or run my tests now, if I just run these tests, for example, you'll see that, that my tests kind of passed. So, so this is a full integration test that is, and we can verify that if you want by outputting the results to system.out, just to make sure we're not think I'm cheating here. But yeah, this is a full integration test that's calling my server over HTTP and returning the results, and it executes really fast. So that's building a basic Micronaut application. Now, how do we make this application into a serverless application? So one of the things that you can do with Micronaut is, if I go to my build.gradle here, and you can do the same thing with Maven, we have an equivalent. You'll see that Micronaut has this notion of a runtime, which is by default using Netty. So when I run my application, I'm starting up a Netty server. But what I can do is I can swap this out. So I can say, I want to use Lambda as my runtime, right? So I'm changing to use Lambda to basically AWS Lambda as my kind of runtime. You'll know this by the fact that if I actually try and start my application now, I can't actually start it from the main method because Lambda it's serverless, right? There's no server, so I can't run it locally. But I can actually run my tests. So And Micronaut has some great features. So if I run this test and execute it, the test will pass, and that's awesome. I have the same test. I've switched my runtime over to Lambda, and Micronaut will actually has test implementations based on Jetty that simulate the Lambda environment, so that you can basically write tests for your Lambda functions. So this is really awesome because I can write a test, and it's exercising all of the Lambda infrastructure needed to write a serverless application, but is essentially spinning up kind of mock Jetty server that simulates it. And that's really cool because I don't have to change anything about my code, and I'm running on Lambda. So one thing I want to demonstrate as well is, when you're building multi-cloud serverless applications, you often want to make your application adapt to different clouds. So I have this default book service, and the way you can do that is through requirements in Micronaut. So for example, if I were to create another implementation here, let's call it AWS book service, and let's make it implement book service like that, and implement the method, and then maybe we can just go across to our default implementation and paste that in there, learning on AWS Lambda. You can spend like different responses, and what you can do is we can come to the default one, and we can say that this implementation requires that there is no other implementation of book service. So if there's no other implementation of book service, load the default. And on the AWS one, you can say that this is another singleton bean, but it requires the environment to be Lambda. Right, so my application can be and the Lambda environment is automatically available when you build applications that deploy to Lambda. And now you can see that my application can adapt to running on one cloud or another. And I can take this further by creating another class. For example, this is Oracle Book Service. And this one implements book service as well, and we can implement all those methods, right? And return them. And let's have a look on Oracle Cloud, and we return different message here, like so. And basically make this a singleton, and we can say this one will be present when the environment is Oracle Cloud. All right, so we have an application that's going to adapt to run on different clouds, and this could be calling, like, for example, some database, autonomous database on Oracle Cloud, or on AWS kind of managed RDS, whatever. And you can have your serverless function adapt to the different environments that it's going to run on. Okay, so I've built this now into I've set my runtime to Lambda. And one thing with Lambda that's different to a traditional application is you have to be careful, and in general with serverless applications, is you have to be careful to the memory limits. I actually took some notes here and because we actually build, when you're building native Lambdas, we build them inside of a Docker container. And you can supply these additional memory settings, which are recommended for serverless applications, because even when you're building with native image, you basically, it's native image is like another virtual machine that if you don't specify the memory limits, it'll just eat up what is available, and you can hit the Lambda and a memory limit quite quickly, and that will bring instability to your serverless function. So setting the maximum heap size % to 80 will make your memory consumption stable. And then also we found that these two netty flags do help with regards to using HTTP client. These are kind of optional if you're going to use the HTTP client in Micronaut. which is based on Netty. It's a good idea to set these to, which again, optimize memory consumption. So I'm going to set those two flags. And what I'm going to do is I'm going to go over to Gradle here and to my Gradle kind of tasks. And I think that there's one called build native Lambda. So I'm going to set that off, building my native Lambda and build it into a native image. Now this will take some time to actually build the native image. So in the meantime, what I'm going to do is I'm going to switch over to the Lambda console. And as you can see, I've got some Lambda functions here. AWS Lambda functions. We got Micronaut. This one is actually Micronaut starter. So this is the one that we continuously publish the backend for Micronaut launch to. As you can see, it's running behind API gateway. But you can it's running behind you can send like requests to this. So there's the URL. So if I copy that, for example, and I can actually hit that in a browser, I think it'll probably redirect to Micronaut launch. But yeah, because that's the kind of default for the root URI. But yeah, you can. This is essentially Micronaut launch running serverless. So what you want to do is you want to click create function and you want to click author from scratch. And we're going to say this is like a bookstore function or something. And then you want to choose the runtime that's going to be provide your own bootstrap on so we're going to do a custom runtime. We're going to do x86. See anything else in here we need? We're going to use an existing role. So I've set up a role for Lambda basic execution. And we're going to create that function in the Lambda console. So there's no code for this function yet. So we're in the middle of building that. And it's still building, but it's nearly there. So this is where we're going to upload our function to. And to test it out, you can use an API gateway proxy request. So this is going to be just like a test request where we're going to send here the kind of just the path to books with a get method and everything else. I don't think we need. So we can just get rid of that for when we actually test, send a test request. And we can save changes for the moment and come back to our code. So it looks like my Lambda was built into a native image. So what you can click is upload from zip file, upload. And if we go to dev.micronaut JCON serverless demo, in the build directory, we've got our built Lambda zip for my Micronaut application. Oops, what did I do? Clicked something I shouldn't have clicked. Open, save. And it's a 14 megabyte zip file, so it concludes the complete native image and the bootstrap. So it's going to take a little bit long time to upload. Hopefully not too long on my internet connection, but basically in the oh, there we go. So it's uploaded. And now you can see we can trigger that test event, and you can see the learning and understanding Micronaut on Lambda. So the Lambda environment was activated and we're getting the Lambda response. We can see that the init duration, the build duration for that cold start was 500 milliseconds. Once the function is actually warm, you can see it's dropped significantly. And my Lambda is deployed, my application is running, serverless application is running, and it was pretty simple. Now, I could actually expose this over the internet. I would have to add a trigger that is an API gateway request to make a request to the actual Lambda. That's why I'm using a test event, which is going to hit it with a API gateway proxy request. But basically, yeah, that is my Lambda solution. So So now let's have a look how we can take the same application and deploy it to Oracle function. So one of the things you can do with Micronaut is if you have the command line installed, you can say mn feature diff, and you can choose features Oracle function. And that'll show you the differences you should probably recommend to make to your application to deploy to deploy to Oracle functions. So one of the things we need to do is we need to specify a Oracle function uses container registry and Docker for functions. So we need to set up a image we want to publish to. So I have my Oracle. Well, the first thing you need is your Oracle Cloud tenancy. So I'm going to use the regions. I'm using the region, which is Ashburn, Oracle Cloud Container Registry. And then what you want to enter is your cloud native, your tenancy name, which in my case is cloud native temporal. And I'm going to publish to my Graeme Rocher repository, and I'm going to call this bookstore, and you can include your project version like so, etc. And then one other thing that with Oracle functions is you need to use a base image, a serverless base image. So I'm going to set my base image to the distroless base image when building for Oracle function, and publish my function up to Oracle function. And then the final step that we need to make is we need to set the runtime to Oracle function. So when I set my runtime to Oracle function, and if I run my test again, once again, we have the same experience for Oracle function in that we have a kind of test Jetty server that simulates the Oracle function execution environment. Looks like somebody caught a problem. Oops, yes, there were 2 dots in Dashboard. Thank you for the people that are awake and paying attention to mistakes. Otherwise, that would go horribly wrong. So once we've done that, what we can do is once again go to our Gradle tasks, and we can go to upload. And there is I'm going to use Docker push native. So, and I'm going to click that, and this is going to build my application into a Oracle Cloud function and push it up as a container image into my Oracle Cloud infrastructure. And in the meantime, we can head over to the Oracle function application. So in Oracle function is slightly different to Lambda in that you have function applications. So I have a function application. Oh no, my session has expired. So I have to log in again. Oops, let's just log back in. Go back to my functions dashboard in Oracle functions. So I have 2 function applications here already set up. And each function application has, you have to kind of create the function from, create them from here. And so what I'm going to do is I'm going to create the function. Probably we're going to have to wait a little while until the native image is actually built, which will take a few minutes. But basically what you do is when you create a function, you give it a name, and you have to give it a kind of the repository that you want to resolve from, and then the image and various settings, since it's all based on Docker and container registry and so on and so forth. So we have to fill in these little details. And then the other thing that you have to do is with Oracle function is to access it over the internet, you have to set up a API gateway in order to invoke the function over the web. And we'll do that afterwards. But first we need to wait for this to finish building. It's nearly finished. So into a native image and published up to Oracle Container Registry. So Oracle Container Registry is another service where all the kind of images are published up to. So all images go into, all my kind of Docker images go into here, which is where I'm publishing to. Okay, so let's go back to my function application. Looks like it's just uploading it. So it's pushing my image using Docker push native up to my, and it's done. Okay, so now what we can do is create a new function, and let's call it the bookstore function, whatever it is. And we have to choose my container registry. So let's see, bookstore, there it is. So there's my function. We're going to leave those. I'm going to increase the timeout just a little bit and just increase the memory. And we're going to click create. And we're going to create that function, that function. So it'll take a little while to spin up, and then what? But basically, that's my function created. And then what we want to do is we want to go over to API Gateway, and go into. I already have some gateways set up, and in API Gateway, what you want to do is go to deployments and create a new deployment. And this is going to be my bookstore deployment. And we're going to use the path prefix of books. And click next. And then what we want to do is route all paths to my Micronaut application. And you can limit the methods. So I can say any, and what I want to do is I want to choose the backend type of Oracle function and choose my application and the bookstore function to route all everything to there. And then so that all looks good, hopefully. We click create, and it will create my deployment. And it'll take a minute to actually create the deployment. But once you have the deployment, it'll be available on this URI, which is your kind of endpoint, which I can copy. If to help with debugging and so forth, you can enable execution logs. And in fact, I think you can do that for the function as well. So if I go back to my function, which I deployed, you can come in here and I believe into your function application and enable logging, which I already have some logging set up. But anyway, so the gateway function the deployment should have completed being deployed now. So let's have a look, which it is. So looks like it's deployed. So now we can go into a terminal window here and just use curl to try and invoke it. And it should go off if my demo gods are with me. It should go off, and obviously, now with Oracle Cloud, it's the cold starts it really puts the whole infrastructure to sleep. So the first request with regards to the cold start will take some time. But then I believe there's like a 6-hour period where it doesn't put the application to sleep entirely, and subsequent requests will be very fast. So there we go. My application is deployed. So the learning Micronaut on Oracle Cloud. So we've got our application, our bean that was specific to Oracle Cloud injected into my application and operating in a different way on a different cloud. So that is the demo of multi-cloud serverless. So some tips with regards to building applications. Pay attention to your memory settings when going serverless. Like I said, if you hit the memory limits of the serverless platform you're deploying to, it'll likely just error. So do configure your resources appropriately for deploying. You should supply configuration to your functions. Don't hard code it into application.yaml. So if you're using a database or anything inside your function, Micronaut provides great integration. You can either use environment variables for the function, or you can use AWS parameter store, which we have great integration with, and Oracle Cloud Vault in Oracle. So you can actually enable those, store all of your secrets, and the function will resolve the values from those independent systems, and then execute your function. And then automate all your deployment. As you know, I'm obviously building locally, but automate your deployment on CI. So if you go to the Micronaut launch application, we actually do that with GitHub Actions, and we have workflows that deploy Micronaut launch to all the different cloud providers. Specific to each cloud platform, for Oracle function, use the distro space image and make sure you publish the container registry. So where can you go from here? So I've provided you with a demo of what you can do, but we have a lot more learning resources for Micronaut. Building serverless applications. So if you are if you want to build an Oracle function and deploy it to Oracle Cloud, we have a guide for that. If you want to build native applications and run them on Google Cloud Run serverless, we have a guide for that. And if you want to do the same thing with AWS Lambda, building native applications that run Lambda, we have a great guide for that. So these are great resources that you can check out to continue and go through kind of self-paced guides where you can explore more. So in summary, Micronaut provides multiple options to create and deploy serverless applications in a completely cloud neutral way. So you can see that application I built had nothing specific to the cloud. I was able to deploy it to Lambda. I was able to deploy it to Oracle Cloud. It was able to adapt to which cloud it was running on. And all of those features are just built into Micronaut in the way it works. And you can use GraalVM native image to optimize your serverless applications, cold starts, and memory usage. So in both the case with, and I believe even with Oracle Cloud, in fact, the memory, you can stay, thanks to native image, within the 128 meg usage limit. And the cold start on Lambda is with native image. This is it's like 500 milliseconds. It's phenomenal. And once your application is having any kind of use with Oracle function as well, that it boots up very quick, boots up extremely fast with native image. So that is the presentation. I have some time for questions and Q&A, I hope, and let me know your thoughts. Oh yeah, and also if you look in the chat, there is some Micronaut training that you may want to check out, and a promo code to get access to that. So do check it out. So I'll wait around if there's any other questions. But, I hope you all enjoyed the presentation, and that what it was revealing in terms of what is possible with serverless applications. Micronaut, it's really come a long way, and the serverless integration is pretty seamless now. So it's a kind of much loved feature of Micronaut these days. Lots of folks come to Micronaut for serverless. Okay, it looks like we don't have that many questions, so I must have been in the height of clarity with my presentation. So thanks everybody for attending, and see you next time, hopefully. Thanks a lot. Thank you.